Hi, it's me. This is exactly what NASA's official Voyager account tweeted a few days back to celebrate Voyager 1's comeback. Finally, after 5 months of gibberish, NASA has received a message from interstellar space in a way that makes sense. Considering everything that has happened in the past 5 months, this is nothing short of a triumph to be celebrated. At 15 billion miles away, Voyager 1 holds the title of the farthest human-made object in space. The spacecraft has been traveling for nearly half a century now. However, due to a glitch that led to a chain of confusing communication patterns, the last 5 months have been very stressful in the spacecraft's history. NASA engineers working on the fix faced 2 serious challenges. First, the spacecraft was built more than 5 decades ago by people who have long since retired. So the present team needed to go very deep into the old documents to see how the probe and its computers worked. Secondly, the technology is highly outdated, although several software updates have been carried out in recent decades. As a comparison, today, even the cell phone in your hand can handle more than 100 billion instructions a second. On the other hand, Voyager's computers can process just 8,000 a second. But what exactly was the glitch that took so long to fix? Why didn't the traditional strategy of turning it on and off work? Finally, and most importantly, is the issue completely resolved, or is there something else that needs to be addressed? The Voyager spacecraft, just like computers on Earth, uses the binary system to communicate with us. It employs only 2 numbers, 0 and 1, representing all kinds of information. Each 0 or 1 is referred to as a bit, and a combination of these bits can represent anything from numbers and letters to more complex data like pictures or sounds. There are 3 main computers on board Voyager 1, and it has turned out that the glitch was linked to one of them, called the Flight Data System, or FDS. The FDS is responsible for collecting 2 types of information from the spacecraft: data from scientific instruments designed to study the universe, and data related to the spacecraft's own health, indicating if all parts are working correctly or not. After collecting this information in binary format, the FDS processes and combines it into a single data package. This package is then sent to the second computer, the Computer Command System, containing the Telemetry Modulation Unit, or the TMU, which transmits this package back to Earth. To do so, the binary data are first modulated onto a carrier signal for transmission to Earth. Once this is done, the TMU transmits the waves carrying the data received on Earth via the Deep Space Network, or the DSN. The DSN is a collection of large radio antennas strategically placed around the Earth, such as in California, Spain, and Australia, to ensure continuous communication with different spacecraft as the planet rotates. Once the binary data are received, they are further processed in data centers. The binary data are converted into human-readable formats like numerical values, graphs, or images that are further used for analysis and research. Since the spacecraft was launched, it has been sharing information this way. But for the last few months, instead of sending the usual mix of scientific information and spacecraft health data, the TMU was sending a strange and repetitive sequence of 1s and 0s that didn't make any sense. For some reason, the FDS wasn't handling the information correctly, since a piece of incorrect information was reaching the TMU from FDS. The TMU was transmitting irrational binary messages back to Earth. Usually, when such a problem arises, the first solution is to restart the FDS by turning it off and back on again. This approach often fixes most technological problems here on Earth, and even in space. For example, back in 2010, when Voyager 2's data showed a similar issue due to a flip in one of the bits, the team performed a resetting command for the memory of the FDS, which successfully resolved the issue. This on-off mechanism even solved a glitch faced by the Hubble Space Telescope a couple of years ago. Following the same strategy, a reset was also performed on the FDS this time, but that didn't help. The problem persisted when the system was turned back on. This prompted engineers and scientists to devise more robust solutions. The Voyager team achieved a breakthrough after months of meticulous troubleshooting. They finally identified that a faulty chip was the root cause of all their problems. But how did they come to know about it? In March 2024, the mission team sent a so-called poke command to the FDS. A poke command is a direct way to modify the values stored at specific memory addresses of a computer. This is typically used for performing low-level operations, mostly in older computer systems. Using poke, a programmer can directly interact with the system's hardware by changing values stored in its memory. For instance, in some old computer systems, like the Commodore 64, if you wish to alter the text color, you could achieve that using the poke command. Each color is denoted by a number, and the text color is managed by the value stored at a specific memory address. By executing a command like poke 646,7, you could change the text color to yellow. Here, 646 represents the memory address responsible for the text color, and 7 signifies yellow. This command gives programmers precise control over the system's physical features, making it a valuable tool for implementing exact changes to the hardware's functionality. Now, returning to Voyager 1, the poke command enabled engineers to instruct the system to utilize different readout sequences in its software packages in an effort to resolve the problem. Eventually, after the team received a response from the FDS after 22.5 hours, engineers noticed some unusual readings from one part of the system. The readings seemed to be formatted incorrectly. After carefully interpreting the confusing signals, the engineers obtained a complete readout of the system's memory. By comparing this readout with one taken before the problem occurred, the Voyager team identified the source of the corruption. It was discovered that about 3% of the computer's memory was corrupted. One chip responsible for storing a portion of the FDS memory, including some of the computer's important software code, wasn't working. And this is why turning the computer on and off was of no help in November 2023. What was the solution now? The spacecraft is billions of miles away, and there's no way to repair the chip. Given this, the team decided to relocate the affected code to another location in the FDS memory. However, no single location is large enough on the computer to hold the entire code section. This prompted the team to devise a plan to divide the problematic code into pieces and store these pieces in different parts of the FDS. But again, it was more than a one-step process. To ensure the code pieces still functioned together, they had to modify them and update any references to their locations in the FDS memory. The team initially isolated the code responsible for handling the spacecraft's engineering data and relocated it to a new location in the FDS memory on April 18th. As mentioned earlier, it takes about 22.5 hours for a radio signal to travel to Voyager 1 and another 22.5 hours for a signal to return. However, this time, the wait was worth it. When the mission team received a response from the spacecraft on April 20th, they discovered that their changes were successful. For the first time in 5 months, they could monitor the spacecraft's health and status, indicating that their fix had been effective. The contact with Voyager 1 was never truly lost. It was more akin to being on a phone call where you can't hear the other person. But now, we're finally able to hear it again. However, this is just the initial step. In the coming weeks, the team will continue to relocate and tweak the remaining affected parts of the FDS software. Once these adjustments are made, Voyager 1 will soon be ready to start transmitting scientific data again. The data sent by Voyager 1 are critical because the probe is now in a part of space where the sun's influence is weak, and it's telling us about things like cosmic rays and magnetic fields in a place we've never been able to study directly before. However, as Voyager 1 travels further away, staying in touch gets more challenging. Signals take longer to travel, and they're much weaker by the time they reach us. Despite these challenges, Voyager 1's journey continues. It's not headed towards any particular star or planet, but in about 40,000 years, it will pass relatively close to a star named Gliese 445. In human terms, this is a long time, but it's a blink of an eye on the cosmic scale. The sad reality is that Voyager 1's days of collecting science data are numbered. The two Voyagers have been exploring the cosmos for nearly half a century. Their power is projected to run out sometime beyond 2025. After that, they will silently drift through the Milky Way, possibly for eternity. Scientists are hopeful that the spacecraft will continue to send scientific data until the mission's 50th birthday. Recently, the James Webb Space Telescope measured how fast the universe is expanding. The results have confirmed the biggest crisis in cosmology, showing that our best model of the universe is broken and that we are missing something. If you missed this episode, be sure to catch up on the exciting discovery.